Hi, so this is a part 2 to what we were doing just a minute ago when my phone decided to stop recording. So we're going to pick up with this equation where the GCF needed to be factored from the polynomial first. And we're solving for the zeros of the function here. So x squared is when you divide x into x cubed, you're left with x squared. When you divide negative 10x squared by x, this exponent subtracts that minus this exponent, which is understood to be 1, leaves you with 10x. And when I take 25x and divide by x, I'm left with 25. This should look familiar. When we were doing completing the square the other day in class and singing completing the square song, which I will post to another video, we look and we inspect this to be half of 10 is 5, and 5 squared is 25, and we're recognizing this to be something called the perfect square trinomial, where your result of factoring is a binomial squared. So recognizing that 10 and 25 are related in the way that if when you take half of this number and you square the result, you get that number. So this is the half of b squared scenario equals the c. Okay, and that leads you to a perfect square binomial, which always factors into whatever the sign is, plus minus, and the half number. So b over 2, and then quantity squared. So in this case, it's going to be a minus. So I'm going to have x on the outside, which you can't forget, and x minus half of 10, 5 quantity squared, which is the same thing as saying x minus 5 times x minus 5. And I'm going to leave it that way because I want you to see how that root is something called a repeated root. Now, our t-chart, because we're setting this equal to 0, our t-chart now has 3 sections. It has this section and this section. So each of these 3 factors, this in fact is not a quadratic. It is called a cubic polynomial because the 3 here means that it has 3 roots to the function. X equals 0 is one of the roots. The point is 0, 0 that this graph will travel through. 0, 0 is on the graph. It's part of the solution. X minus 5 is a root where x equals 5, 5, 0 is the coordinate point. And again, a repeat, x equals 5 again, 5, 0. And in a graph, what this means is that the graph will not travel through that point, but will be tangent at that point, meaning they will be a turning point at the point 5, 0 on the graph. So if I have this function, right, this function travels through the point 0, 0, but then it does this sort of thing where it hits the point 5, 0, and then turns and goes back up again. And so the cubic function has opposite end behavior, and it goes through this point because that point's only represented once, but then it's tangent to this point because this point is represented twice. And that's what it means graphically speaking. So if you were to relate the two to the graph, you would find that this event happens, okay? And that happens anytime there's a repeated root. So as soon as you see there's a repeat in the factor, then automatically you know the graph doesn't go through, it actually touches it and turns around. So it's a turning point right there. And what's called a relative min, actually, which you'll get more into when you take Algebra 2. Okay, the last equation I wanted to show you was another function, but a little bit different, where there is a GCF to factor out, but that GCF is not going to lead us to a root. Okay, so looking at the equation, 3, 15, and 18, you could factor it this way, but it's a little bit difficult because you've got a lead coefficient of 3. And so you always should ask yourself, whenever you have a lead coefficient other than 1, you should always ask yourself, is this a factor of the other 2 terms? Because if it is, we want to factor it from the polynomial to start. So that 3 is in fact a factor of 15, and it also is a factor of negative 18. So we're going to factor it from the polynomial, making it equal 0, and leaving x squared plus 5x, 15 divided by 3 leaves 5, minus 18 divided by 3, 6. Okay, now this, in fact, can be broken into 2 sets of parentheses. The 3 stays on the outside, and we factor this trinomial, x and x. I need factors of negative 6 that when added together give me positive 5. So my numbers are 1 times 6, 2 times 3, and that's all I got for 6. I need different signs because I need to make a negative product, and so it's going to mean I'm going to be subtracting to get 5. And the only way you could subtract to get 5 is with these two, 1 and 6. So I place the numbers 1 and 6 here, and you think, what does, the middle term has to be a positive, so in order to get more positives, I need to make this a positive factor and that a negative 1. So x minus 1, x plus 6. And you should always, after you factor, especially if you're new at it, do a little quick check on yourself. First times first is first, last times last equals last, and then you look at your inner 2, which is negative 1x, and your outer 2, which is 6x, and when I add those together, I do in fact get 5x. So you just always want to make sure you've got it straight and that the signs are correct as well. All right, now, if I were to take this, 0 equals, and if I were to break it into 3 pieces, because 3 is a factor, however, it's not going to be a factor that leads to a root, because if I set 0 equal to 3, this does not make sense, and so this is insignificant. What you could think of it like this is, if I were to divide both sides of the equation by 3, then this 3 would cancel to a factor of 1, and 0 divided by 3 would still be 0. So a constant factor will not have an effect on the other factors, and so I will just break this open, set them each equal to 0. This, if you want to go to the side and just write 3 does not equal 0, and just let that fall away, and then add 1 to both sides, you get 1, x equals negative 6, and so my roots of my function are negative 6, comma 1. Okay, so this goes through the point 1, 0, and this goes to the point negative 6, 0. And the last point I want to make today is just the idea that you can have 2 different functions, and they could have the same zeros of the function, but they might not be alike at all. So keep that in mind as you're doing some problems, because sometimes the parabola can go upside down. And remember, those upside down parabolas have a negative lead coefficient. So a negative lead coefficient could travel through the same x-intercepts as a positive lead coefficient and be 2 separate functions. So just because they have the same zeros doesn't make them the same. The same goes true for the vertex. 2 functions could have the same vertex and yet open very differently. We saw this when we were stretching parabolas by changing the lead coefficient. Okay, that's it for today. I need you to make sure you're up with all of these notes if you need to watch it again and write some things down. Again, this is a 2-part video because of my little interruption before. And stay tuned this time tomorrow for another video lesson related to quadratics and quadratic functions. Okay, have a great day.